Let's take a quick look at a displacement time graph. So this is going to be a graph which relates the displacement s as a function of time. And as a body moves, its displacement changes so that its displacement s is a function of time. And a graph plotting s against t is called a displacement time graph. So we might have an axis, a y-axis, which is displacement in meters, and an x-axis, which may be time in seconds. And for this example, let's suppose the time scale is something like this: 1 second, 2 seconds, 3 seconds, 4 seconds. And let's suppose the displacement goes something like 2 meters, 4 meters, 6 meters, and minus 2 meters, minus 4 meters. Remember, displacement is a vector quantity. It has a magnitude and also a direction, so we can have negative displacement and positive displacement if we're talking about the one-dimensional situation. Now, supposing we have a displacement time graph like this, shown in blue. This could be an example of the motion of a ball thrown in the air and falling back to the ground. And the motion of the ball can be described by looking at the graph. The ball starts at the origin and starts to move in the positive s direction. It moves upwards and it reaches a maximum height of about 6 meters. It then falls back to the floor, so it starts to move with decreasing s, and it falls right down to the floor, which is here, which is about 4 meters below the point at which it was released. And it all does that in about 5 seconds. So in terms of velocity, while the ball is moving upwards, it has a positive velocity, and while the ball is moving downwards, it has a negative velocity. Now we know that velocity equals change in displacement. I'll just write displacement over time. So at any instant on its journey, I can think about the velocity at any instant being simply the gradient of the line at that point. Think of a triangle there, not very well drawn, but I can think of the displacement divided by the time. So the gradient of a displacement time graph gives us an indication of what the velocity is. So on the first part of its journey, the gradient is positive, but after about 2 seconds, the gradient starts to reduce until it's 0. And at that point, after about 2.5 seconds, the velocity is 0. And then the ball starts to fall. The velocity starts to increase, very well drawn, and we have a negative gradient, so we have a negative velocity on the final part of the journey until it hits the ground. So in summary, the displacement time graph shows us the motion, shows us the displacement as a function of time, and the gradient of this chart shows us the velocity